Hi guys, so we're going to go through page 18 and 19 in your Unit 3 packet. So make sure you have page 18 out in front of you. It looks like what is on the screen here. And I'm going to take you through this just like I would if I was in class. So there's going to be times when I tell you, hey, pause, go do this problem, and then you're going to come back and check your answer. You really need to make sure you do follow and stop and pause and do the question and then do the one I tell you to do next, because we are going to work out of order on this worksheet. So this worksheet doesn't really go in order of difficulty, so I'm really going to have you skipping around. So make sure you pay attention to what I have you do next. So we are going to start, like we usually do, by adding some notes to the top of our page. And so first, let's add in some graphs, because we are working with both phase change and temperature change today, which is new for us. Okay, so over to the side here, let me get my pencil. I'm going to draw two graphs, and you should do this along with me on your paper, because these notes are going to be really helpful. So if you remember, when energy goes into a system, it can do one of two things. It can change the phase, the state of matter, like solid to liquid, liquid to gas. That looks like a plateau on a temperature time graph. Or it can change the temperature. That looks like a slope on a temperature time graph. So again, this one is a phase change, a plateau, versus we could also have a temperature change or a slope. Now, we've also learned the two equations to deal with both of these things. So we learned that for phase change, we use the equation Q equals mH. And for a temperature change, we use the equation Q equals mc delta T. So make sure you get both of those written down at the top of your page, because that's going to be so useful for you to refer back to them. And another friendly reminder, so here we have all of our constants, again, for water. So remember, this is only for water. If you ever have a substance that's not water, these numbers won't work. But most of the time we're using water. So for water, these are your H's. You use those with that top equation. And down here, these are our C's. You use those with Q equals mc delta T. Don't mix them up. You can't use a C as an H or an H as a C. So the H's go with Q equals mH, phase change. The C's go with Q equals mc delta T, temperature change. One last thing I want you to note, and you can draw this wherever you have space. I'm going to do it over here in the corner. Water has two plateaus, and we should know where they are. They're at 0 degrees Celsius and 100 degrees Celsius. Sorry, my lights went out. Okay, so it plateaus at 0. This is where it melts, heats up, and plateaus at 100. So whenever you go through 0 degrees Celsius or 100 degrees Celsius, you're going to have a plateau with water. It always plateaus at 0 and 100. So you really have to remember that. Okay, so again, take a second, pause this if you need to. And actually, I'm going to add in one more thing before you do that. We added these in when we did MH. Let's add them in again. Melting and evaporating are endothermic, they're positive, and freezing and condensing are exothermic, they're negative. So add those in real quick. And again, if you need a minute to write these down and make sure you get all those notes at the top of your page, go ahead and pause the video real quick. Okay, so let's take a look at the first question, question number 1. The first thing you're going to do with all of these questions is you are going to draw the heating curve. Erase these numbers that carried up from the top. So you're going to draw the heating curve. That's the temperature time graph. Remember, temperature's on the Y, time's on the X. So it says how much energy must be absorbed by a 150 gram sample of ice at 0 degrees Celsius that melts and then warms to 25 degrees Celsius. So I like to start by writing in my temperatures. Always write in the temperatures on your temperature time graph. It's going to be really helpful for your math. So it melts. Okay. Melting is a phase change, and then it warms up. So take a second, pause the video, see if you can draw this temperature time graph. So now you're back. It melts. That's a plateau. That's a phase change. And then it warms up. That's a slope. So it goes through a plateau and then a slope, a phase change, and then a temperature change. So it has two regions. So we're going to label this first region here Q1 and the second region Q2. It's going to be super important that you label really well on these problems because you're really going to need to keep track of your work. If you're not keeping track of your work, you're going to have a hard time. Okay, so we got Q1 and Q2. So now we just have to calculate Q1 and Q2. And the good news is you've already done this. This isn't any new math right here. So Q1, if I go back and look at the top of my page, I see that's a plateau. On a plateau, I use the equation Q equals mH. I know it's melting, so I'm going to use Q equals mH sub F. We just did problems like this. This should be pretty fresh in your mind. So I just plug in my numbers, 150 grams times 334 joules for every gram. Stick that in my calculator, and it comes out to be 50,000 joules. It's technically supposed to be rounded to 2 sig figs, but 50,000 joules as 1 or 2 sig figs is the same number. So we can leave it as 50,000. It's okay. Okay, we got Q1. Easy enough. Let's calculate Q2. Q2 is a slope. So if I look at the top of my page, I'm going to see, okay, slope, Q equals MC delta T, temperature change. So I need to use MC delta T. And then I just go and plug in my numbers. Still 150 grams mass. It's liquid water, so we use 4.18 as our C. And then final temperature, I like to look at my graph for this. It ends at 25 degrees Celsius. And it started, that slope started, just this region started at 0 degrees Celsius. So I put that in my calculator, I round it to 2 sig figs, and I get 16,000 joules. Okay, here's the good news. The last part is the new part. So it's new math. And guess what? It's just addition. Praise be. So we're looking for Q total. Here we go. Q total equals Q1 plus Q2. That's it. So my final answer, 50,000 plus 16,000 joules, 66,000 joules. So that question was a little more math than we're used to. But all in all, it's stuff we've already done. So it's actually not as scary as it looks. The hardest part of these questions is getting the right temperature time graph. Because if you don't get the right temperature time graph to start, your math is not going to follow. So I told you we're going to be skipping around a little bit on this worksheet. So like I promised, I want you to go to number 6. So go all the way to number 6. And I want you to start by drawing the temperature time graph. So I'll get you started on it. Your ice starts at -7 degrees Celsius and it warms up to 22 degrees Celsius. Now I want you to add one more number here. Remember I told you about how water plateaus at 0 and 100? Well, somewhere between -7 and 22, it hits 0. So I want you to add in 0 there because that's an important number for water. So pause the video and take a second to draw this in. Okay, so hopefully you remembered that at 0 for water, that's a plateau, which means from 7 to 0, it was warming up, and from 0 to 22, it was warming up. So we got ourselves a 3 region 1 now, which means we're going to have 3 equations. Something else I think that's important to note here is it starts as a solid, and then it melts on this plateau, and it ends as a liquid. That's going to help us for our equations when we do MC delta T. It's going to help with specific heat capacity. Okay, so you have to calculate Q1, Q2, and Q3. Why don't you go ahead and try to do that on your own? And you can even try to get Q total. And so you'll come back here and check your answers. So again, calculate Q1, Q2, Q3, add them all up to get Q total, and come on back when you got it. Okay, take a second to check your answer. I'm going to talk through a few key points here. So Q1, it's a solid, it's ice. So we need to use the 2.1 joules for every gram times degree Celsius for our specific heat capacity because it's a solid. I rounded this to 2 sig figs because my 7.0 has 2 sig figs. This 0 here doesn't count towards my sig figs because it wasn't given to me in the problem. That I just knew was the melting point of water. It's what we call an exact number. So it doesn't count towards my sig figs. Q2, it's melting here. That's endothermic positive heat diffusion. So I use my 334. Note that I get 3 sig figs here because my number 235 had 3 sig figs. So even though Q1 had 2 sig figs, Q2 is allowed 3 sig figs. Q3, I use my specific heat capacity of liquid water because it's melted. Now it's liquid water, I need a different specific heat capacity. And again, 2 sig figs on that one from the temperature, so 22,000 joules. And then remember, I add them all up. Note that I don't round sig figs again once I add them. The sig fig adding rules, as long as it's a whole number, I can just add them all up and leave it. So don't round it again. You already took care of your rounding. So 104,000 joules is going to be your final answer. Okay, so as promised, we're going to keep skipping around. So I actually want you to head to question 3 now. And the difference for question 3 is going to be energy is removed. So you're going to have some negatives here. You're going to have a cooling curve. So first things first, I want you to draw your cooling curve. Hit pause, draw that, and come back and check just to get your cooling curve. Don't do the math yet. Just get the cooling curve, hit pause, and come back and check it. Okay, so did you remember to put in your 0 there for your plateau? So this is another 3 region, Q1, Q2, and Q3. So we cool off from 25 to 0, freeze, and then cool off from 0 to -12. So again, pause the video once you've got this down and calculate Q1, Q2, and Q3. I'm going to give you one tip. Watch your positives and negatives. In these cases, it's either going to be all positive or all negative. You're not going to have Q1 and Q2 be negative and Q3 be positive. That wouldn't make sense. It's either all endothermic or all exothermic. So if you have one odd one out, that's the wrong sign. You probably either messed up your T final, T initial, or if it's a phase change, you messed up your H. So they should either all be positive or all be negative. Keep that in mind and come on back when you finish that problem. Okay, so let's check your work and do a little walkthrough of the important parts. So Q1, that's liquid water. So I use my 4.818 specific heat capacity. And notice I have to watch the order of my final minus initial temperature. It ends at 0, that's the final, starts at 25. So that's going to make that Q negative, which makes sense because it's cooling off, energy is coming out. Q2, it's freezing. So I need to make sure I make my heat diffusion negative. Again, they're all going to be negative or they're all going to be positive. And on those phase changes, you have to be smarter than your calculator. You assign the negative or positive. So negative 110,000 joules. And then Q3, 340 times 2.1. It's ice now. So we use the solid specific heat capacity, your temperature change, and the negative 8,600 joules. Then I add them all up. And once again, note, I don't round again at the end. If they're whole numbers, you can just add them all up and leave it. You already did the sig fig rounding. So make sure you feel good about those types of problems where we're solving for Q total. If you don't, go back, try them again, and figure out what you're getting stuck on. So we need to be good with this Q total business before we can move on to the more algebra heavy problems. So we're going to move to question number 2 now. And I'm going to work through I'm going to start this one with you together. Because this one, we're going to have to put our algebra hats on for. We're doing the same thing, but you're going to notice right away, it gives you Q. 325 kilojoules. First off, let's change that to joules. That's what I always like to do right away. That is Q total. It's giving you the whole thing, the whole Q there. It tells us this energy goes into 450 grams of liquid water at 20 degrees Celsius. What mass of the water would be boiled away? So we are assuming, if we draw the temperature time graph for this, it starts at 20 and then it goes up to 100 to get boiled. It tells us it's boiling. I know boiling happens at 100. So it's saying all of the water completes Q1. It all gets up to 100. But not all of the water gets to Q2. Remember that Q total equals Q1 plus Q2. And let's write down our equations for Q1 and Q2. So Q1, we know the whole thing is making it to 100 degrees Celsius. So this is just business as usual. 450 grams times 4.18 times 100 degrees C minus 20 degrees C. And that gives us a Q of 150,000 joules when we round to sig figs. Okay, so Q1's easy. Q2, that's where we don't know what's going on because we know the full 450 grams doesn't evaporate. So I'm going to leave that as M. But I do know it's evaporating, so I do know 2260 joules for every gram. Okay, so I can't solve for M right now because I don't know Q2. So if I knew Q2, I could solve for M. So let's see if we can figure out Q2. Well, I know Q1 and I know Q total. So up here, we'll do 325,000 joules equals 150,000 joules plus Q2. So look at that. I can figure out Q2. I just have to subtract 150,000 joules from Q1 from my Q total, which means Q2, it's going to erase this here, equals 175,000 joules. So remember, Q total, this 325,000 joules, is equal to Q1 right here plus Q2 right here. So when I add these two together, they should equal 325,000 joules. So since I know all of Q1, I'm able to figure out Q2, and then I can just divide both sides by 2260. Little algebra there. Little algebra there. And I get my mass. So my mass ends up being 77.4 grams. Okay, so that one's not as scary as it looks. It's a little tricky because we have to calculate that Q1 first and then subtract Q1 from Q total to get Q2. But then once we've got Q2, we can solve for M. Okay. So we're going to try this on our own now for question 5. Okay, now question 5 doesn't look like you're solving for mass, but it's saying, will the sample of water completely freeze? So you have, by the way, you can rewrite this as 400 decimal point grams. Saying you have 400 grams of water, will it completely freeze? You're solving for mass. So if your mass ends up being less than 400 grams, then no, it won't freeze. And if it ends up being more than 400 grams, then yes, it will freeze. So I'd like you to give that problem a shot. Solve for mass. Come back when you've got it. All right, let's talk through a few points of this one. I didn't fully show my work. If you look at my copy of the key I posted in the same page, you will see my more detailed work. I just posted a little snippet of my work here since we've done a bunch of these problems at this point. So I did not show my work for Q1, but what I got for Q1, so I'll label that Q1 there, is negative 100,000 joules. You need to watch your negatives on this. Notice how my Q total, I made it into negative 250,000 joules because it said the energy was removed. So whenever energy is removed, we have to make that Q negative, and that makes a big difference here. So then when I add over the 100,000, that gives me negative 150,000 joules equals Q2. And I went ahead and replaced Q2, the equation, with M times negative 334 joules for every gram. So again, all I did was just cinch up my algebra here and this work. But if you look at my picture of my key, the work is fully expanded. So when I solve for M, I get 450 grams. If you're going to make a mistake here, it's probably this step right here, actually, where you didn't have the negative, so you ended up with 350,000 joules over here. And so if you ended up with a really big mass, check this right here and see if you ended up with 350,000 joules. If you ended up with 350,000 joules, it's because you forgot to change Q total to be a negative. So that means it will all freeze. I have 400 grams, 450 grams is bigger than 400. It's all going to freeze. So that's good news. So if you're sitting in class right now, this might be about the end of class. This might take you to the end of class, or maybe you didn't even get this far in a class period. It's a lot of work what you've done so far. So if you have time, continue on to the next thing, or if you're continuing this at home, keep going. But if you're in class, take a look at the bell and see if you actually have time to continue on to the next thing or not, because this should cut you pretty close to what we had time to do in class. Okay, but either way, you're finishing this online, so maybe you're picking this back up with your online work. And let's pick back up at number 4. Okay, so we're scaffolding here. So I am going to show you less and less as we go on. This time we're solving for final temperature. It's going to be very similar to solving for mass. So let's draw our heating curve. So this one, we've got 165 kilojoules of energy added to our ice at 0 degrees Celsius. It's ice. It's asking what's the final temperature of the water. We're going to draw this one together real quick. It melts. It heats up. This is a question mark. I'm going to erase this leftover 6, the other problem. That's a question mark there. We don't know what the final temperature is. So it's okay to call it question mark. We just don't know. Or you can call it X if that makes sense to you. That's what we're solving for. We don't know T final. That's cool. Okay, Q1, Q2. So what I want you to do is I want you to calculate Q1, subtract it from Q total, and set up your equation for Q2. So I will be back with you when you've got it set up as your Q2 is going to be an MC delta T. So I want you to fill in everything in Q2 except for T final. That's what we're looking for. So when we come back, you're going to pause, work out the problem. When you come back, you should have everything filled in this equation except for T final, because that's what we're solving for. And again, you're going to work it the same way you worked number 2 and number 5. It's just now we know the mass. We don't know T final. So pause, go work it out. We'll be back in a second. Okay, let's check in. Remember, I'm giving you some real simplified algebra here because we've already gone through these problems. You can check my picture of my key. My algebra is more detailed there. So for Q1, you should calculate that out to be 50,000 joules. If I subtract 50,000 joules from 65,000 joules, Q total, Q2 should be 15,000 joules equals 150 grams times 4.18 times T final minus 0 degrees Celsius. Okay, so that's where we're starting. Hopefully we got that far. Now the nice thing about this being minus 0 degrees Celsius is anything minus 0 is still itself. So I can just get rid of that and it's just TF. So that makes my math a little bit simpler because anything minus 0 is still itself. So it doesn't matter what temperature it is. If it's minus 0, it's not changing the temperature. So I'm just going to get rid of that minus 0 part in the parentheses, make life a little easier. So you would just multiply these two numbers together, which would give you 630 joules over degrees Celsius, technically would be your units there, times T final equals 15,000 joules. Divide both sides by 630, and we get T final is equal to 24 degrees Celsius. And voila, there you go. These are the hardest types of problems, solving for T final. So I'm going to let you do number 6 on your own. So go ahead and do number 6. You can check it with the key that I posted a little lower on the page. Sorry, not number 6, number 7, last question. Number 7 is actually the hardest question on the page. So go ahead, take a shot at number 7, check it with the key, and then for your online work, you're going to do the challenge problem I posted in your folder. So good luck. If you have questions, if you're looking at this before Friday, feel free to sign up for office hours on Friday. If you're looking at this after Friday, you'll have some time to ask some questions on the Google Meet next week. So I'll see you all in Google Meet next week. Have a great day.